Hello everyone, welcome back. Let's start today's lesson. Sorry for waiting for so long. So whenever we have a new device, we want to test whether it functions or not. So if there's a hello world function for hardware, I'll call it a blink test, meaning that there's an LED light that can blink over time. So let's try to see whether we can run this test. So starting from this terminal, we open the ESP-IDF terminal to create another project. So IDF.py create project. Let's call it blink test. And here we have the blink test. Let's go to open the blink test terminal in the terminal. Blink test. Here we are. We have a new project here called blink test. There are several things we have to do first. First is to open the ESP-IDF terminal so that we can build, flash, and monitor the project. Another thing we would like to is add the VS Code configuration folder to this project so that VS Code won't show any errors if we see some variables or functions. And here on the bottom left, we'd better change the build target and the USB path. First, to locate your ESP32-S3 button is the device target. Make sure that you have chosen the correct one, ESP32 and the ESP32-S3. And after seconds, it says that the target ESP32-S3 set successfully. And also, make sure that your desktop or Mac can detect the USB device that is connected to this device. Here we have the ESP32-S3 and I think it is. So port has been updated to this. And these are the preliminaries we have to do before build the project. And inside this ESP-IDF terminal, let's see whether we can build the project or not. IDF.py build. Okay, so it seems that we have to full clean the project if it's not clean. So something in the build should be not correct. So let's run full clean first. So this will delete everything in the build folder to start a clean rebuild. All right, so we can build the project, and after some seconds, we will know whether it is successful. So during the same time, we can start write our functions. And this is a blink test. So we will have a very simple main function here. And to run a blink test, we need several packages. So the first is the FreeRTOS to run some time-dependent coding. And also we have some tasks, so to run the blink test. And also remember that this is a board, so we have to visit its general purpose IO port. So we must have the driver GPIO.h to see that we can access the LED GPIO. So then if we want to print something, we have ESP log.h to see we can print some logs or not. So depending on what kind of board we have, so locate some numbers on the board, and you can see that we have a board with a GPIO2 that has an LED light. So here, so we set the blink GPIO to this as the second GPIO port. So okay, so let's start configure the GPIO first. Configure the GPIO pin for LED. So GPIO reset pin. So make sure that we have reset it to make sure that it is reset to the initial status whenever we install this function to this board. So then we set the direction of the GPIO. So since we want to make it flash, so it must be the output to produce high or low electricity level to make it blink. So, and then inside this function, so we make it loop forever. So how to blink the lights? So first we set it on. So we set the level GPIO 1 means delay for 1 second and turn on the LED lights and then delay 1 second. And then set the GPIO level output level to 0. So like delay, turn it off then for 1 second. And we make it run forever. And so whenever we want to see some information, we may need to print something in the log. So GPIO log blink LED totaled. So here, so this finishes the function. And let's see we can build this function or not inside this terminal. So here, let's magnify a little bit. So here, we see the function and let's build again. All right, so why we need this test? It is because on the GPIO, the LED can run as a basic test to test whether your board is okay. And beside this, if we want to see something very simple as a print or debug function, blinking is a very good test. For example, when you want to print something but you cannot see it on your desktop or it is runtime on board, we can show blink to verify some function is ready, or blink twice to show some error, or blink 3 times, 4 times, depending on whatever function you have, and the blink is just a sign for debugging. It's very simple and easy. So let's see if we can flash it or not. So IDF PI flash monitor. So make sure that your board is connected to your desktop via the USB connection and flash it, and we can open the monitor window to see the debug information. Okay, so it starts flashing. All right, so let's record a video for this. So here we are. So it is blinking and here we go. So we have finished our second or this part, and let's see whether we can open the Wi-Fi in the next session.